Alright, welcome back to the next video on the next concept of this chapter on sequences and series. And in this video, we're going to jump into one particular type of sequence, right? And that is called an arithmetic progression. So I just want you to have a mental model for yourself when it comes to this concept first, before we actually jump right into it, right? So what exactly is an AP or arithmetic progression? So an arithmetic progression is basically a sequence. Okay, so an AP is basically a sequence. It's just a sequence where the difference between each term is a constant. Okay, so I'm just going to give an example of what an AP is over here. For instance, let's say we have this sequence. Okay, so remember, a sequence is just a set of ordered numbers. For example, 2, 4, 6, 8, 10, 12, right? And then let's say ends here. We know that this is term 1, term 2, term 3, term 4, term 5, term 6, right? Okay, and then let's just assume that it goes on infinitely. So since it goes on infinitely, we say that this is an infinite sequence, right? But of course, this is not important in this context. That's not the thing that I'm trying to focus on here. The thing that I'm trying to focus on over here would be the relationship between each term. So we can see that between each term, the difference is just a plus 2, right? You can see that the difference over here is a plus 2, and this carries on and on and on. So term 1 would just be 2, but we also can say that it's 2 plus 0 of 2, right? Because for the first term, there is no addition yet. Now for the second term, T2, this would be 2 plus 1 time of 2, right? You can see that everything basically just starts from the first term. So to reach the second term, you start from the first term, which is 2, and then you add a common difference of 2. Now for the third term, T3, right? This will basically be 2. You start from the first term, and then you add 2 how many times? 2 times, right? And this gives me 2, this gives me 4, this gives me 6. Now in case this example is not too clear yet, because there's a lot of 2's on this page, I'm just going to change the numbers. All right, I'm just going to change this to 3, 3, 3. Okay, so let's just change this sequence over here. Let's say this is 3, this is 5, this is 7, this is 9, this is 11, this is 13, right? And then here would be 3, 5, 7. Right, so you see some sort of a pattern over here, right? The thing that we can observe is that every single term over here will all start from the first term, right? So for the nth term, the Tn term over here, it will also start from the first term, which is T1, which is 3, right? It doesn't matter which term it is. It doesn't matter whether it's the 5th term, the 7th term. It will all start from the first term, which is 3. Now, to get to the nth term, how many times must we jump forward, right? You realize that for the first term, we jump forward 0 times. For the second term, we jump forward 1 time. For the third term, we jump forward 2 times. So every time we have a term, the number of times you must jump forward to get to that term is basically n minus 1, right? That's the pattern that you can see over here. So for instance, let's say you want to hit the 10th term, you have to jump forward 9 times, right? That's the sort of the pattern over here. So we know that this would be n minus 1 of the common difference, which is 2. So to generalize this, right, for the general term of any AP. Now, once again, what is considered as an AP? An AP is a sequence whereby the difference between each number is a constant. Okay, so this is different from the other type of sequence, which is called geometric progression, and that will be something that we'll be discussing in a later video. But just note that for now, a difference between any consecutive term, if it's a constant, then it's called an AP, right? So the general term of any AP, right, will be this thing called the Tn equals to T1 plus n minus 1 of d. So as you can see, for any AP, right, the general term can be generalized as this, where T1 over here is the first term of the sequence. Alright, and then D over here is the common difference. You can think of it this way. And then n minus 1 over here is the number of times I jump in front. Right, you can definitely think of it this way over here. So this is basically what an AP is. And in the subsequent videos, we will be talking a lot more about, the different concepts involving an AP, some of the cool things that you can be doing for an AP, and even things like how do we even test for an AP, right? But at this point, all you need to really understand is, what is an arithmetic progression, which is basically a sequence, but a very specific type of sequence, whereby the difference between each term is a constant. And the general term of any AP can be generalized as such. Okay, and once you understand this, then you are good. You have known enough to try these mastery questions that we're going to try on the screen over here. So we have 2, right, for this video over here. So I'm going to zoom into the question over here. Feel free to pause this video right now to tackle this question. If not, I'm going to be going through the question right now. So continue watching this video once you are done with it. Okay, so let's tackle this question head on right now. It is given that the first 3 consecutive terms, so T1, T2, T3, right? They are 6x and 92. So we know that T1, T2, T3 is 6x 92. And since this is a very specific type of a sequence, which is an arithmetic progression, we know that the common difference between each term is just a constant, right? So this is D, D. So plus D, plus D. So the first thing that we need to figure out is what is the common difference over here. And the common difference, remember that since each term has a difference of a constant between each other, we can form a pair of simultaneous equations fairly simply, right? The first thing we can say is that x is 6 plus d. That's equation 1, right? And then the next thing that we can say is that we can say that 2 or negative 2 is x plus d, right? And then from here, we can rearrange the equation to make x the subject, right? So from here, we can derive that x is minus 2 minus d, and this is equation 2. So you got equation 1 and equation 2 already, whereby you have 2 equations and 2 unknowns, and then from there, it's fairly straightforward to solve it using simultaneous equation. And since this is the A level already, you don't need to show the working of deriving the values for a simultaneous equation, right? That is considered fairly trivial already in the grand scheme of things when it comes to this syllabus. So from here, you can just plug the values into your GC and derive the values. So from GC, right, you get that x is 2 and d is 4, which is, it does make sense, right? Because from 6, I minus 4, I get 2, right? And then 2, I minus 4 again, I get negative 2. So it does make sense, right? So we know that the common difference is d over here. So this is the common difference. Now, how do we actually answer the question? So we are asked to find the 5th term of the progression. So before that, in order to find T5, let's first formulate how the general term of the progression will look like. So I'm going to let Tn be the general term of this AP, right? Just note that we can write AP lah, right? Or if you want to spell it out, it's also fine, but short form is also good enough, right? So Tn can be written as the first term, which is T1, plus n minus 1 of d. And to contextualize this, we know that the first term is 6, and then n minus 1 of the common difference of minus 4, right? So apologies, here is minus 4, right? D is minus 4. So therefore, for T5 would therefore have a value of 6 plus 5 minus 1 times 4, right? Because we are essentially jumping forward 4 times by a value of negative 4. And therefore, all in all, this will give me a value of negative 10, which is the final answer to this portion over here. Now, the question over here says, find the expression for the n term, and we know that this is the expression for the n term, but of course, for the final answer for double I, we will simplify this, right? So for double I, just simplify this. So whenever the question asks you to give the expression for the n term, that means you have to really simplify it. If not, you can just use this over here to help you calculate this, because writing it this way allows you to see the pattern, right? But of course, if they want the full expression, then we have to simplify it lah. And what I mean by simplify this is just expand this. So 6 minus 4n plus 4, right? Which is tn is 10 minus 4n, which is the final answer. So when you have to really simplify it, then you just expand it, right? If not, all in all, this is the answers to this question over here. Let me know if this makes sense to you in the comments, and if you got any questions, just let me know in the comments as well. If not, we will go on to the next question. So feel free to pause this video over here to try this question out. And as always, if not, I'll just jump into this question right now. So we have AP, and we know that T4 and T9 is 16 and 39 each. So from here, we know that since, or rather T4 is 16 and T9 is 39, right? And we know that this is an AP, right? So I'm just going to let Tn be the general term of this AP, right? And we know that Tn is basically T1 plus n minus 1 of D, right? But of course, we don't know what the T1 is and we don't know what the D is yet, right? But we can definitely find it out by observing this pattern over here. So I'm just going to zoom in. Okay, so imagine this. I have T4 and T9. Here's 16, here's 39. From T4 to T9, right, I jump a total of how many times? I actually jump a total of 23 times, right? Because I basically jump a total of 23 times over here. Now, when I jump 23 times, right, how many D do I add to T4 to get to T9? So we know that T4 is essentially T1 plus 3D, right? We can think of it this way. And T9 is basically T1 plus 8 of D, right? Because to get to the fourth term, you essentially add the common difference of D 3 times. So you can also say that T1 plus 3D is 16. And you can say that T1 plus 8D is 39. So what happens when you take equation 1 and equation 2 and then you minus them away from each other, right? So if you take equation 2, minus away equation 1, you end up with 5D equals to 39 minus 16. And 5D essentially is 23. So solving for D is just 23 divided by 5, right? And therefore you get the common difference as 4.6 over here, right? So you get 4.6. So the common difference in this case is 4.6. And therefore it is very easy for us to figure out what's the first term, right? Because all we need to do is to just sub this back inside here. So subbing this back inside there, we get that T1 is 16 minus 3 of 4.6, which will give me a value of 2.2. So the first term is 2.2, and the common difference D is 4.6. And therefore, this allows us to very, very easily figure out what's the n term, or the general term for this entire equation over here. So Tn is 2.2 plus n minus 1 of 4.6. Tn is 2.2 plus 4.6n minus 4.6, right? 4.6. Tn is therefore 4.6n minus 2.4, which is the final answer to this entire question over here. So you can see that knowing the general term of an AP is very, very useful, right? Because once you really understand how the general term is being formed, you can literally use it to find any term in the whole entire sequence, or even, use the idea of it to help you calculate what's the first term and the common difference. So with that said, that's all for this video over here. In the next video, we will actually be jumping into a slightly more complicated formula, but I'm sure that if you understood this video, the next video shouldn't be a problem for you as well. Any questions, let me know in the comments below. If not, I'll see you in the next video for the next concept.